So now. Hey, this is Brooke Drum with Printrbot.com, and we are live here on Facebook, and later, unlive with YouTube and Vimeo. But welcome. So check this out. Got some stuff to show you. First and foremost, I want to... Okay, this is going to annoy me, this noise here. Can you hear that through the... Kind of? Well, the good news is we got the Adoptable files. We did some more changes to them today, and we have them posted. The link to it, I'm just going to unplug this. I know that it prints. Hold on. Okay, good enough. The Adoptable model is here. In fact, since I just unplugged it, I'll show you. I'll take you through a couple of changes that I made and why the very first model that I released, if any of you were super eager and went ahead and printed that version. My Z height needed adjustment. Anyway, this is the Adoptable. And what I love about this, I showed it last week, but this week it was printing. So it fits in the palm of your hand. So you can see this on a little desk for a student. You can do one per student, but I don't know. That's a lot of printers. But this little guy, the files were done last week, and I had to drill out a couple of holes, and I think I see here I took the soldering iron and melted down part of this to get the clearances right. So after I got it like hacked and I knew what I needed to change, we went into the model and did some changes on the hole sizing, and we actually did post a little test piece. So when you see that test piece, it looks like a little arrow. You want to point that to the right. And first, you should, before printing these parts, you should check that part because those holes match the same holes we use in the models for the printer here. Do you know if Mark got all those done or not? Did he say anything before he left? Mark, the Adoptable files? I always see these emails when these guys update the files, so I can't promise you that everything is done because I haven't looked at it yet. But I think they're all done. So what we do is like when we use 3mm like M3 screws and the plastites, they use the same through hole. So we use, I think it's a 3.5 or something like that. I forget what it is. But we use a certain size ID, inner diameter, hole. Like if you were to measure the inner diameter of the hole, we need a certain width for that screw to pass through without like having to drill it through or turn it in there and strip out the excess plastic. So we went through the model, and everywhere where we want to pass through a 3mm screw goes through the hole nicely. Those test pieces should match all of the holes in the model. So there's a clearance hole or a through hole for a M4, which we use on the front of the X and over here on the side with the Y. An M4 actually holds on the little bearings, so it passes through. But when it gets to the other side, it has to bite into the plastic to stay put where it's supposed to be. So that's a different size hole. So we use the next size hole. And then that hole is, the next one is, I believe, the pass-through for the M4, the threaded, I'll call it threaded, even though it's not really threaded, the size hole for the M4 to be threaded into, the size hole for the pass-through for the M3 and plastites, and the size hole for the threaded M3, and then finally the 4 screws that are used for the end stops here are a smaller plastite. I forget what those are. What are they exactly? Yeah. What's the 228 number? Oh. Anyway, so there's smaller plastites here, and those don't need a pass-through because they pass through the end stop or the micro switch, and then they bite into the plastic. They're a thread pattern that is kind of like a wood screw, but perfect for biting into plastic. So that is the last size hole on the test piece. So if you can print the test piece, and all of those pass-through holes, and you can thread into the right holes, then you know that your model is good to go. That we tested on a 0.4 nozzle. I believe, do you know his layer height? You were doing a big layer height, weren't you? But I think he was doing either a 0.2 or 0.3 layer height. Shouldn't matter too much. But let's just say 0.2 because that'll be a little more exact. So when you extrude plastic and it presses into the layer, you know, it actually has a little bit of squish. So if that squish is 0.2, it might react differently than a 0.3 layer height. So anyway, do the test piece first, and then you'll know what to expect on the model here. So on the model, specifically, I wanted to show you the parts that I did indeed update. First off, these bar ends for the X are new. I think I have one here. This is the old one. And it was actually dragging on the ground a little bit. And you can see it's a little beefier on this new model. And I wanted to use the same bed that we use on the smalls. So you actually have a little bit too much bed here. You can't use all of the bed. But when we manufacture, I like to manufacture the same parts if I can. And it was only like a few millimeters off on one side. So I changed the width of the X to get a little more, well, to just use the same part. So these X bar ends are changed, and also the little clamps. The old one looks like this, and it would go up here, and it would clamp down, kind of like holding your work if you do CNC work or if you do woodworking. It just, one screw holds that down, and it clamps right here with that little wing nut. So anyway, it's got the bed a little higher, it's wider, and it's thicker. So that works out really nicely. It does require a slightly longer belt, so I'm a little bit nervous about that. If I have to, I can move in. I'll have to check that. I just realized the screws over here, because I had my belt for the more narrow bed, I had to actually use longer screws here, but I could adjust that in the model if I need to, so I'll double check. Either that, or we'll just ship this with longer belts. So anyway, those two bar ends and the clamps were one. Also, it was funny because I forgot the last fan shroud. I didn't have a sensor. I couldn't find my sensor part, and so we actually glued a regular sensor mount. What is this used for? This was for the smalls. This is a small sensor mount, but I've always wanted to have the sensor mount hide the sensor, and this happened to be the right height. So what we did is, instead of just gluing it on here, you can see it, these levels drop down a little bit. We combined those two parts, and so now the sensor and the fan shroud are the same part. That was glued, and this is the sensor mount. I know I'm getting a little technical, nobody cares, but what you have to do is put the wire through here, and then you can load the sensor. In fact, it's so tight, I don't even have a screw in this one to tighten it, but we'll have this. The screw's already there, I just didn't put it on. So that holds the sensor and the fan shroud. And then on this side, because that just has a little press fit to go into the blower fan, it wasn't strong enough because it has to hold the sensor. So we added a little through hole here for an M3 screw to hold it up into this part, which is the part. And you can see there's a little hole right here. So this goes in, and it screws together right there, holding it nice and tight. So it's only one screw, but it's plenty. So that worked out really nice. Now, some people have been asking about this fan shroud. You know, I haven't tested it much, to be honest, but it is somewhat restricted on this hole size for this blower fan, but the blower fan puts out a lot of air. And it fits in here. I could make this a little bigger, and I'm expecting the community, and this is true of this entire design. The files are released, they're out there, you can download them, you can print them with just a few parts, you can put them together, and the Adoptable people are about to do that. But, oh, by the way, Dave, if you would post, I don't know if you already have, Dave took a picture of the UPS guy, USPS person, loading, so he shared that, so there's evidence that we have shipped it. Now, I don't know if we shipped them all. There's a couple of screwy address things. We got any left?
Only one. Yeah, they're all shipped.
Okay. They're all shipped. I remember there was one guy that snuck in from Canada, and I was like, well, we got to talk to him. No, we're not going to do that. Anyway, so some already have theirs and probably waiting on these files, and the rest of you, they're on their way now. By the way, this sensor mount, it does have 2 different size holes on the top of the shaft of the sensor. I don't have one, but it's a little smaller than the threaded part, so it's supposed to be that way. You just push it up on that. But anyway, so that fan shroud is a little bit unconventional because it's one fan blowing through a slightly restricted hole, and then it actually, this triangle, and it's a triangle because it prints like this, and you get nice clean edges on a triangle. You can see that. Otherwise, you're going to, if you have a square, it's going to have a droop. I always hate that. So the size of that triangle may need to be restricted or opened up. I'm not sure. You could put a little can around. If you've got a UBIS 13 like this one, we could put a little shroud so the airflow is directed around and then down. But anyway, it's a beginning, and it does have air coming out here and at the bottom to cool the part. So that's that. These parts are new, the bar ends are new, and the clips on the top are new. Is there anything else? Oh, yeah, there is one more. In fact, here it is. So this is the back plate for the Z. I made a huge mistake in the model on this one. The little couplers we use, they are custom made. I don't have one, but it's on this one. They're very small as far as diameter. The reason they're small is in the simple, to get more high, was it the simple or the smalls? But anyway, I designed these little bitty printers, and if you use an off-the-shelf coupler, they're like this big around, they're huge. Like the size of a hot dog, you know, link or something. And if I make that smaller, then I can get more travel and use a shorter rod and all that. So I use these really tiny couplers. I don't intend for any of this to be proprietary. And in fact, now that the files are released, I'd love to see people, you know, use a different hot end, use different electronics, make different choices than I can. Here's your marching orders. We need to save cost. So I'm open to, you know, you don't have to use me as your sourcing chain for tiny couplers, and we can make different decisions on this rod or the hot end, the extruder, and all that. I don't care what you use. What I care about is getting these printers in schools for kids or adults. But I made a big mistake on this because I had this big block here, and it totally just jammed into the coupler, and it was like ½ an inch from hitting the bed. So I had to hog that out with a soldering iron to test it, and then once I got my dimensions, I redesigned the part. So this one is also new. So there's 1, 2, 3, and then those little clips, 4, 5, 6 new parts were changed, and then we made sure all the holes were proper. So the models are there and done. I have had requests for, hey, what about the electronics? They're exposed, and that's dangerous. It's not really dangerous. It's 12 volts. You can just about put your tongue across those leads, and you'd be okay. Don't do that. But I understand people want to make it either look or be safer, and I'm all for it. So there's clearance here to do a really tight case around this. So if somebody wants to go crazy and design a little clip-on case, I'd love it to be clip-on. It's kind of shocking when you look at the nuts and bolts, or the vitamin bag, as I call it, for this printer. Since so many things are kind of sandwiched and use the 4, you know, screw holes on the motors, a lot of this goes together without, you know, having to tap into plastic and do a whole bunch of nuts and bolts and all this. The only nuts in here, I think, are on these belt clips, which are absolutely necessary. But the count for the hardware bag is like this little bitty guy like this. I don't remember how many nuts and bolts parts, but it is very few. So I'm pretty excited now. I have been printing on this, but not very much, so I'm not going to lie to you. It's not even got, I don't even want to tell you. It hasn't printed much, but it does work, and I've printed my test cubes, and it's looking like it's going to be great. Now, I have shipped these out with the volume down to where it needs to be, the build size volume. It's just the firmware for a simple. And then we size down the build volume. And then we actually turn down the speed by limiting the acceleration. Well, we actually turn on the acceleration like down to 40 or 50, I forget. It's something that you can change, but I want to print slowly. What I like to do is start with our expectations low. And if a kid, for the first time, he gets to 3D print, he's not going to be thinking, well, man, it's 40 millimeters a second, and like, you know, Ultimaker does like 70 millimeters a second, and this sucks. They may say, like all newcomers to 3D printing, is that as fast as it goes? It's pretty much as fast as it goes. All 3D printing is pretty slow when compared to, you know, walking to Target and buying something completely finished. But it's a superpower, so we don't mind going slow. And with this bot, like, this was something that my original printer for the Kickstarter, people would say to me, you know, I'd have it printing at a show, and, you know, it prints pretty good. And, you know, these belts were old XL belts and, like, all sorts of regular lead screws from, like, Lowe's. There's all kinds of trade-offs to get this thing cheap. But they'd walk up to it if it wasn't printing and like, do this, and, like, look, this is... And they just wrench on this and say, well, that's not very strong. But the forces that this undergoes when printing is very slight. I mean, gravity doesn't take much for these lead screws to just hold off gravity. It's not going to drop. But yeah, these you can manhandle this thing and it'll wobble. And, you know, it's what happens when you use plastic parts. So if somebody walks up to the little Adoptable and holds the base down like I'm trying to do, and starts wiggling stuff. Well, this isn't very sturdy. Look, I can twist this, or I can grab the front and do this. Well, it's like the old joke, don't do that, especially not while printing. It never undergoes that much force. All it has to do is enough force to just move this bed back and forth, to move this head back and forth. And I did notice that the first few times I built this, when I was going up with Z, you know, the force of me turning that Z, you can see, I don't even know if I can hold it still enough. If you really start cranking, you can see it wobble, but all I had to do was adjust it a little bit on the set screw to make sure, I don't know if it was hitting the wrong part of the lead screw or what it was doing, but it only moves up 0.2, 0.3 millimeters in layer height per time. So I have yet to do any big, tall prints. It's only got 95, I think, millimeters. So anyway, it is a minimalistic printer that is a great entry. Nothing to be scared of. If you break a part, then you can print another part. If you want to modify it and upgrade it, make it more sturdy and do all of that, I welcome you to do that. These are press fit. In fact, I cheated on these. Let's see if I can get these off. They're not that tight because what I did is I have these reamers, which I do not expect you to buy. I have these reamers that, a reamer is like a special drill bit sort of, and it's 10 thousandths. When I switch to English stuff, I like metric, but it's very, very little. How do I explain this? 10 thousandths of an inch under the size of an 8mm bar. So it's slightly smaller. But this plastic, and especially when you hand drill, you know, your hands wobble around. It ends up being just like the perfect size to press on, and it's pretty tight to press. So these might take some dialing in the model. There it goes. So you can see it holds it tight enough. All we're trying to do is keep it at the same distance apart, so when this traverses up, it's not like getting bent because it's more narrow at the top than the bottom. So it's just kind of a placeholder for these bars. So anyway, there's your explanation of the files. They're ready. So go for it. One note, and I did a little, by the way, I did a little unboxing. Is that link live? Can you share that link if they want to watch it, or is it not?
It's on our Facebook video feed, but I haven't finished it. You have to wait for Facebook to make it available for downloads.
Okay.
Maybe up by now.
It's a gift from my daughter here, Jack. It's a Christmas present, I think. But anyway, so Dave was explaining that we did an unboxing for we use these little It Fits, It Ships pack from USPS. What do those cost to send? It's 8 pounds, but it doesn't matter the weight, right?
Yeah.
Is is it 13 bucks or 14 bucks, somewhere around there? I guess does it depend on where it
Yeah,
is?
it's regional.
It's regional.
Actually, always more.
Yeah, those boxes, I had one guy that the first few that we sent out, he said, oh, this got damaged, you know, and it's like the box is ripped on one corner. I think I got to send him a couple more motors. He said his motors were damaged. But anyway, I know it's not the most awesome packaging, but it is cheap and it's predictable. So it's sort of a fixed cost. It's the average of the shipping in the U.S. It's the best way to go. And it actually fits in that little box with room to spare. So even if we did end up shipping kits with the parts included out to people that are building, there's even room for the parts, the printed parts in there. So I think it's the right choice. But though, what was I going to say? I lost my train of thought, sorry. Anyway, that's the Adoptable. Oh, I know what I was going to say. In the video that I did earlier, I explained this, so if you watch this, the other one, you can skip past this. But one thing I am pretty jazzed about this little guy is, if you go back a few years, nobody was using these auto level sensors. And I know that the exact term is tramming. It's an induction sensor that uses its proximity to, it's like a magnet that senses when it's close to metal. So going back a few years, I think we were the first manufacturer. There's people experimenting with this, especially on Deltas, but we were the first manufacturer to put this sensor in there, and we use them in all our printers. You don't have to. Some people don't mind, and especially about this size, wouldn't mind a little adjustment in the plate, but if you wanted to use a micro switch for Z, this part could be redesigned. You could put a little switch there if you wanted to. Or maybe you'd put it back here so it's out of the way of the tip when it's traveling around, not dragging the little arm on the micro switch. But anyway, we could switch this to use even older printer boards, like going back to Rev D. And I have a bunch that I'm hoping that some people from the electronics team actually rework and get working again. But you could use end stop for Z as well, and you wouldn't need the complexity of the, I say complexity, you know, you wouldn't need a sensor. It's really straightforward. In fact, you don't even need end stops. My first MakerBot, I would print without any end stops. You just start your print instead of homing. So anyway, there's a lot of potential here, and I'm excited to finally get past that first hurdle. It took me forever. But all right, there it is. So now that we're done with phase 2, or was that phase 3? I don't even know, but here's the deal. Moving forward, now that we've shipped all of the Adoptable that I sold in my store here, and if you're watching and didn't even know what this was, essentially Adoptable is a program that we've started within Printrbot but are moving outside of Printrbot. And it's now a website. Excuse me, my coffee's making me burp. There's a sound bite for you. The website is live, although it's completely not done. If you want to see my embarrassing first pass on the website, it's adoptabot.org. And the adoptabot.org has a link on the front page, I believe, to the files. And that is a Fusion 360 file that may open something they call A360 on your phone, or it'll open in a browser if you've got a computer. You can look at the model, you can flip it around and spin it and zoom in, hide parts, and look at how it's put together. But you can also download several different formats, even step files, IGIS or IGIS files, and that can be imported to SolidWorks, Inventor, whatever you got. So you can modify the files all you want. I'll post this stuff to Thingiverse's STLs as well, and I will provide like a folder, a zip file of all of the files. I've even got a plate that Mark, he does a lot of the drawing with this, a plate of all the parts. That's not intended to print all the parts at one time. While some people like doing that, I'm like a one part at a time guy, and it all has to fit on this 100 by 100 build platform, so not a lot can fit on there. You could get a few parts, but anyway, I've got a plate so you can see all the parts and how they are to be oriented in printing. There was a guy, I forget who he was, that spread all the parts out on a plate to show, maybe it was Kira, I forget what he used.
I think it was Joel. Anyway, he did this a few days ago when I first released the files. He spread them out on a plate to show, and he had some of the orientation wrong, so I think he corrected that later, but yeah, it does matter. Like he did this. I don't know if you can see that at all, Dave. Is this a waste of time?
No, that'll work. Let me zoom in. That's good. Don't change that.
Don't move.
Don't move at all.
It's good where it is. So you can see that when spread out over the plate, that gives you an idea of what you do need to print. And with the update in the files, that will have to be updated too. Okay, I'm going to turn it back around. But it looks like there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 parts. It's funny because there are 21 parts in this one. So 6 years I've managed to drop one part. Awesome. Some of the complexity of designing this, as I mentioned last week, was I wanted them to print in the right orientation for the best performance for hole sizing. So while the case here, theoretically, you could take the case and the back part of the case and make that 1, and then there's the Z that slides up into that case as so we can be completely flat on bottom because the motor mates to that. So there's 3 parts right there that could have been combined into one. The XZ, this right here, these are 2 separate parts. Because of print orientation, it's better for strength to go around, the bearing. So that prints, like that. So you just rotate 90 degrees and put it together. So there is opportunity for this to be less parts, but it doesn't really matter. Less parts doesn't matter. What matters is it's easy to build and easy to print. So that was kind of my constraints, and in a 100 by 100 bed. So that one big part of the case here, that was really stretching to the limit. So it's pretty tight fit. So if you had a big Prusa or a Printrbot Plus or something bigger, you could definitely fit this. Man, I would think this would fit onto one plate with some clever tight spacing. But then, if you lose your print, you lose everything, which always stinks. So anyway, are there any questions? I got one here. Oh, would it be possible to use something like acrylic for the bed on the Adoptable printer? You would need a couple of options. You could replace the sensor with a microswitch. And again, I think that microswitch would have to be back here somewhere. So the Z that's kind of stationary, just sliding up and down the bar, somewhere back here, where it would trigger maybe the case or something. Then you don't have anything out front here, but that doesn't really matter. But if you wanted to use a microswitch. Now, the reason I say microswitch is because this is a proximity, or it's an induction sensor that senses metal. It won't sense acrylic. So there's 2 options. Microswitch, so it doesn't matter what that bed is. It could be anything, wood, plastic, wouldn't matter, or metal. But acrylic can be used if you go out to Lowe's and you get some, it's this aluminum, it's like aluminum foil almost, but it's really thick. They use it to seal a joint between 2 pipes for like heater, AC, heat and cooling ducting. And they wrap that around, it's real sticky. But you can put some aluminum tape down where the proximity sensor senses, and then you could indeed have acrylic. The reason that question might have come up is if you have a laser cutter or access to one, or you want to just do it on your saw table, you can saw, this is what, 3/16 aluminum. You can actually saw 3/16. You want to set your blade very, very shallow and move very, very slowly. But aluminum is quite soft. We cut it on a table saw. If we have to, we use a water jet for real parts. But somebody could fabricate these metal beds, no problem, just by a hunk of aluminum that's 3/16 or less. And you could rip them into squares and then deburr the edges. Acrylic is really nice on a table saw too, polycarbonate, that type of stuff, and of course wood. And these clips, you might have to use a longer screw if it's a thicker piece of wood, because it's pretty tight. You can see, well, I don't know if you can, but on these wing nuts. There's not a lot of purchase, enough to get it tight, but you could add a bed. And there you've got something that's even more DIY. You know, you can do that with not hand tools, but I mean, you could saw acrylic with hand tools, but I wouldn't want to. So anyway, yes, that was something that I definitely wanted to do. And by the way, while this does not have a heated bed, there are, I don't have them in here, but there are heated beds you could add to this, but don't get ahead of yourself. These kids, these schools, these beginners, they need to walk before they run. So it used to be you'd want a heated bed to do ABS. Now people with heated beds hate ABS. It's like, I don't want to print with ABS. Don't print with ABS. Because it stinks, and you know there's health concerns, which I kind of roll my eyes to. It's as much danger as cooking an egg on a Teflon skillet. But anyway, if you did want a bed, a heated bed, there's lots of options out there, and we do have a heated bed plug here. It's actually screw terminals for a 12-volt DC heated bed that you could adapt. And there's room on the bottom. It'd be pretty tight, but there's room on the bottom. I don't know, half an inch or something, if that, maybe a little less, 3/8 or something, that you could attach a heated bed under here and have a heated bed as well. So that's that. Any other questions on the Adoptable? When do you think Vitamin Group can start sorting for Adoptable? Well, I pulled the pallet yesterday, and thanks for that question. I saw the email. I can ship immediately, so all I need, and maybe I have it, I've got my admin, Heather, she's been helping me. She knows what a crazy brain I have, and I forget stuff, so she helps me keep ordered. And she reminded me of that yesterday. She's like, hey, there's some people wanting some answers. So I was like, yeah, I'll email them. But basically, we have lots and lots of screws and nuts that I'd like to send out to you. I need an address or addresses. Now, it's not a hard task, but there is sorting and bagging involved. So I have bags and what are those called? The sealers, bag sealers. I have a lot of extras of those. So I was going to send out a sealer, some bags, maybe some of our surplus stuff that we don't use very much, like those tubes. Anyway, the point is I've got plastic bags, sealers, and lots of nuts and screws and stuff to sort. So with addresses, I can get that going. So where can Adoptable builders go for support? So Adoptable builder, you are the support. I don't mean that as a joke, really. Now there are builders that won't be doing support for school, so I get that. But we have the model. We added the nuts and bolts today. Although, again, I gave Mark a big punch list, and he only had an hour left at work. But I can continue this. We'll finish it tomorrow for sure. But on the model, there will be where the screws go. So you can technically, I know this is a little bit of work, but before we get the documentation and me doing a build video, and like these nice, if you look at the smalls, the documentation was really well done. You participated in that, right, Dave? In Fusion 360,
It was well done.
he knows how to do it. In Fusion 360, you can take parts, and there's a whole tool in there to help with, here's how it fits together, and it rotates the camera angle, the virtual camera, to look at this side where you can see the screws going in. And so we're going to do all of that, so the documentation is really good. In fact, from a build video, I'd love for a community member to do it for me. That would be awesome. So if you like playing with Fusion 360 and the animation tools for documentation, jump in, because the first thing I'll do is a build video. Now that we have the parts done, I can tear this apart, replace the stuff that I hacked with the soldering iron, and I can show you how this goes together. It's a little bit shocking for me every time I do a bot, because I'm deep in the weeds with the design, and often if I have to replace a part, I have to tear it down and I have to put it back together and test it. But when you're starting from scratch, this goes together really, really nicely. And I was very pleased at how easy it is and how few parts there are. There's always a few little finicky things, but it's funny, like sometimes the finicky nature of it is because I got these big, thick fingers and I can't quite hold the M3 nut in the right place to get the screw in. So if you have smaller hands than me, you'll be better off. Oh, one other change I was going to make on this, I say change, addition, is right here, I had 50 surplus aluminum V1 extruders. And that is not what I'm going to promote for a couple of reasons. Number one, they're expensive to make. It drives the cost up. Second, printable extruders work just fine. In fact, Brian, who designed this, I don't really... When I say I designed something, I didn't draw everything that I've sold here. I stood over a guy's shoulder, and he fixed the crappy drawing that I did and made it like a real drawing. Now this I designed all by myself, but Mark is doing the cleanup work on it. But when he was designing that Alu V1 and then Alu V2, Alu meaning aluminum, machine parts are nice. It actually is kind of cool because it acts as a heat sink too for some hot ends get a little bit hot. But then we started cooling our hot ends with the fan and it didn't matter that much. Well, he had a plastic version of this that he had on his bot, and he had it on his bot for the longest time, and he would do his test prints with that bot. And I was like, you haven't replaced that plastic extruder yet? It was just the plastic version of these Alu V1s, which are available on Umagine and probably Thingiverse, but they're available online. They do print just fine, so you don't have to spend the money for machine parts. And so in a printer that is intended to be printed, I think it's an advantage to have the extruder as a printed part as well. So that's going to be in the files soon. In fact, somebody asked, they had a part break on, they had this little arm break on the injection molded extruder. We did a version of the Alu V2 that was injection molded. But when you do injection molding, you have to rib out, you want to use the least amount of plastic possible for the best strength. And you don't want extra plastic, so it's kind of like ribbed out. I don't have one right here in front of me, but he was like, hey, can I just print a part? And I was like, well, heck, you sure could. And so I sent him the model of the injection molded part and the Fusion 360 file. So that might work, but it requires extra hardware. It was intended for injection molding, being a clamshell design that two parts fit together for the arm. This should be just as simple as possible, so I'll probably do something akin to this, or maybe a beefed up V2. Whatever helps get the cost down and makes it simple. If people want to upgrade, they sure can. You can buy. It uses the bolt hole pattern on NEMA 17, so you know you're going to be using NEMA 17, so you can bolt to it. It's just what size of screw do you need to get through the plastic plate. So upgrades will be possible. Okay, enough of that. So Filament. What is this Filament stuff that I see on the table? Well, this package I unwrapped today. So one of the teams for Adoptable are an extrusion team. And I had a Skype call with 3 of them, which I think is the whole team. There might be 4, I don't know. But there was 3 in the call. And these guys are great. So I really appreciated the time. Spent an hour with them on Skype. And by the way, I'm willing to do a Google Hangout if you got a whole bunch of people, or Skype I think does multiple. I don't know if there's a limit. But if you're a team on Adoptable and you need a little, you know, if you want a little pep talk, if you want to ask some questions, if you just want to hang out with me and we'll talk about the project, I am totally willing to schedule a Skype call. It's just us having a little meeting and making sure everybody understands what they're to do, and maybe we can find some problems and solve them. But the main thing for the extrusion team is the goal, the end goal, is someday I want, and hopefully soon, I want an example of a Adoptable printed with 100% recycled plastic that was pellets that were extruded by the community. Because that's the story that we want to tell. These are community members doing the hard work of learning machines like this. And in fact, Brandon has already, he's on the team, he's already started building from parts he had laying around for a Lyman, I think it's a V6 extruder. The Lyman V6, Google it, great story. This old, I think it was a Navy guy, old timer, somebody had what was it, Protoplaster? Somebody had a contest. Hey, off the shelf parts, extruder, lowest cost, easy to build. Can you do it from off the shelf parts? So he went to Lowe's or Home Depot or whatever, got online at Amazon.com, and he put together a bunch of parts, and he made an extruder that became known as the Lyman. That was his last name. And I ordered the parts for that, and we built one, and it did extrude plastic. And I was like, this is awesome. And then he started revving it, and the community got involved. So now it's up to V something, 6 or beyond. And it got more and more and more. I mean, he had like a water cooler, a little water reservoir cooler. He had like measuring with, I think, an IR sensor or something, the diameter of the filament. He would automatically adjust the speed. So it was like all this technical stuff, and it started to get easier to run this thing. It is kind of slow. But to build your own extruder, I didn't expect the community to do that, although I'm grateful Brandon is doing that. And we're going to get a couple of those Lymans or some derivative that we come up with built and extruding. And so Filament has stepped up, and Tyler's been a friend for a long time. He, CEO, founder of the company. So Filament, go check him out. I don't sell an extruder, but he knows I do promote open source extruder projects. And he knows the difficulty in extruding because he's been doing it for years. So this is the model that Filament sells. This is a EX2. This is a Filament EX2. And this is the extrusion part. And you know, the Lyman would be simple, similar. It's just he's gone with a very basic design that's pretty bulletproof. I mean, look at this stuff. This is really awesome. I like his color choice and all the orange and green. And it's a heater. It's just like an extruder on a printer. It's a big, beefy heater. And you have a temperature control up here and I believe a thermocouple. So you can read the temperature up here. You've got a on switch for extrude, on switch for temperature controller, on switch for mains power. So you get your 3 switches on and you can adjust plus or minus on the speed. Now, there's 2 tips that come with it. In fact, I probably loaded the wrong one. This is, I believe, intended, I haven't even read this. I haven't even powered it on. But this is, looks like 3mm filament. We'll do the 1.75. And so what's interesting about plastic is, you know, it has elasticity at a different elasticity. I don't even know if I'm using the right word, but it's elastic. It expands and shrinks. And temperature affects that. Speed of extrusion affects that. But you dial in your speed so that when it's pulled across these fans, and this is just speed of the fans. I don't even know what the readout's for. Just a power switch, some sort of readout, and the speed of the fan. So this is a dryer that's sold separate. You could make your own. This is industrial. And then he's got these really squishy rubber rollers that actually pull the filament. And then this little guy goes back and forth to assist on getting it on your roll. I used to use literally a drill. And I put a little bobbin on a drill, and we would take big rolls and zzz, but the filament goes all over the place and gets all weird wrapped. This is right here. I wonder how well that works, man, but it's going to take it across and back and try to lay that filament out a little more precisely. It won't be perfect. In fact, there's even a printed part here. This is the spool holder. You adjust the tension on it, and this actually is powered, it looks like. So it does, you get this spinning. In fact, traverse is a dial, on off, and drive, on off. So I assume this will be traverse. So you adjust your back and forth, you know, where it's going to lay down the filament onto the spool. And then the drive is how fast it's going to pull this stuff through. But when you extrude filament, and don't get me wrong, I am not an expert. I haven't even turned this on. I've extruded some filament before. No, I don't even know. Oh. I've extruded some, but not a lot. So Tyler would be the go-to guy to ask questions if you're going to get technical about some of this. But I can tell you that you can, while it's cooling, I said drying earlier, I meant cooling. When you pull it, if you pull faster, it will actually stretch the filament and make it thinner diameter. And it's pretty consistent, keeping a round shape. But if you cool it right and pull it right, and you got all your speeds set, so you know you're going to be bouncing across here, like adjusting things, and then it's going to run perfect for a while, but not forever, because things change. You're dumping, these are the pellets, low temperature extruder purge compound. This is 180C and between 180 and 220C, so there'll be a temperature readout. Must remove filament nozzle during purge. So he sells some stuff that'll clean out when you switch from one plastic to another. There's a slight residue that's left. In fact, Carl was telling me about this because he's got a high temp UBIS 13 high temp, hot end coming out soon, and he's doing Ultim and Peak, and that's 450C. So how do you purge to do PLA after you've extruded 450C and there's a thin like sheen of plastic residue on the inner barrel? Well, you have to extrude at 450C, but PLA is going to be soup. It's going to pour out the end of the hot end at that temperature. So cleaning it is one, or just stick with the same filament every time and then you'll be fine. You won't have to purge, maybe at least as much, maybe never. But anyway, so this is the extruder. Now I'm going to play with this for a little bit and produce some filament, but Tyler is great because he's very, very open. He's got a source for MakerBot parts that are failed. Somebody's up in New York or New Jersey is manufacturing printed parts, and there's a bunch of fails, of course, on MakerBots. And honestly, even on my Printrbot, you know, we have failed parts from time to time. So this company saves them all, and he grinds them with industrial grinders, dries it, and then he can make pellets or similar shavings. He calls it powder, that he can then extrude into recycled filament. Now all the colors go together, which ends up, it's like if you're finger painting and you mash all the colors together, you'll get like a gray. So it's gray. But he's providing, he needs to cover his cost, but he told me today, 4,000 pounds. That sounds like a lot. That's a lot of printing, man. I hope I'm right with that. That's 2 tons of failed parts that he can grind and provide to Adoptable. So he wants to make sure that he is providing recycled either powder that we can extrude ourselves with his equipment, or we can add a price to it and have him extrude it, but that's going to be more expensive. So we've got a great source. Now I also have, what is it, University California Irvine. When I went down there, they had an art installation that they used a bot farm of 30-something, 28 or 32 something, Printrbot simples, and they were printing this art installation with these cool, you called it walking blocks or marching blocks. They had magnets in them, and you could attach them all kind of weird ways and make these really crazy. You ought to give a link to that. It is a cool project, but he printed tons of plastic, and man, the stress of going from 0 bot farm to 30 bot farm, there's a lot of failures that you have in there learning on how to manage all this. It's funny that one of the biggest problems was just where do we hang the filament and so it doesn't tangle. But he's getting ready to do another one. And one of the offshoots of the students there in this art program was recycling. So they had a Filament there, and I got to get on a bicycle and pedal this generator, and it saved up power and a battery that was then used to power Filament. And Tyler probably knows this pulls so much wattage, I bet it powered it for 5 minutes. But anyway, one of the, not the dean of students, maybe it was, but some mucky muck came down and pedaled with me for a while. And the kind of the promise, the story, the promise, the dream of taking trash and making it into something useful, that's not only a dream, it's possible, but of course you have to add manpower or sun power or whatever you're using to get your electricity to have it be truly free and to help the environment. Really, you don't want to. Anyway, that's just part of the challenge. But he was using Filament, and so they've been talking, Tyler and him, about this problem of recycling filament. It's a tough one because he asked Tyler, like, what are the sources for recycled plastic? Like, can we have kids bring in water bottles and like recycle? Well, you don't realize how light water bottles are. And there's very little plastic. They use a blow mold technique, which is like the least amount of plastic possible to make pouch for water to be in. That thing is so light. You would have to grind for a kilogram of, I don't know the exact number, but it would be funny if somebody could look this up. It's, I believe, hundreds of water bottles. And to use those water bottles, think about the final orifice of the printer, 0.4 millimeters. So you can't have any little labels or goo or glue or anything, dirt, in that. It has to be clean. So to clean the water bottles and to make sure there's no goo, so that when you extrude, there's no foreign elements in here, and it can go through a 0.4. It's just a lot of work. And so the actual cost, if you measure man hours, goes through the roof. So recycled filament actually takes more process to use. It's not cheaper, it's more expensive. So when they want to do this recycling program where it's the same or less money as a kilogram of filament. Well, I cheer them on, but it's a tough nut to crack, because he was asking Tyler, hey, where can we get, where are all these plastic bottles that we can just use? He was like, well, it's possible, it's interesting, but I have 4,000 pounds of failed parts. I'm going to be fine for a while. I don't need a source. He's got his source. But I'm sure there's other industrial waste products, or maybe it's a recycling center that does some sort of cleaning, or maybe there's something that we can do. I think Tide bottles are brilliant because they use that like bright orange or bright blue plastic, like Tide bottles. But it's different. You can't just mix a plastic water bottle with a Tide bottle with a shopping, plastic shopping bags. You can't mix all that plastic together. They have to be the same grade of plastic and the same plastic, or it ain't going to stick together. Isn't going to stick together. So it's a tough problem. I'm getting off course. We're here to just show off this equipment, to thank Tyler, to have you go consider Filament if you're looking at an extruder, because he gave me this stuff. This is like, I think the price on this is, now he sent this to me free, and I'm passing it right on to a community member, and it's going right into the Adoptable cause. But this first piece of equipment over here, the EX2 filament extruder, is $24.99, so $2,500. And then this dryer here is, oh, that's weird. I have the wrong, unless I'm looking at two invoices. I don't know how much this dryer is. I don't know if Filament, what is this called? The Filament Air Path. $649. So already we're up to like $3,100 or $3,150, whatever it is. And then this spooler is $1,200. Now that may sound like a lot of money. I mean, it is. It's a lot of money. But let me tell you, it's a guy like there's Kickstarters with. I bought a cheaper filament extruder on Kickstarter, and Carl has it. ReadyTech or ReadyTech. They're in Canada. And I got to tell you, the build quality on it is fantastic. We must have got one of the first ones, because Carl went to use it, and Carl's no slouch, and that's putting it lightly. He couldn't get it to go. He manually could turn the dials and okay, there's the settings I want, but when he put it into the firmware, it didn't work. So he's been trying to help them get that rolling. I think it's quite a bit less than this setup, but I don't know about the speed difference. It has a hand grinder in it, which is kind of neat. But when I get that back from, actually, I may have told Carl he can keep it. I don't remember. I do that with Carl. He gets to play with all the cool toys. But anyway, the price on something like this is intended for not industrial use. Like, I don't think you would find, Protopasta using Filabots for the amount of filament that they move. But they could probably save some money, actually. But, it's the speed at which you can do this, and how nicely it spools and all that. It has yet to be seen, but I know that Tyler is doing some extrusion that does sell on the market for companies that are doing exotics. So this is more of an industrial style. It's a tier below. You might have to buy a grinder is probably $7-8 grand. An industrial grinder, a small one. A dryer would be similar price, and then to process pellets. And then to extrude, we're talking tens of thousands of dollars, up to 100 grand, I'm sure, and beyond, to really get plastic, going through for mass manufacturing. But this is for desktop stuff, so may sound like a lot of money. I don't think it is, because it's a superpower and you can get out your checkbook and just do it. He didn't ask me to do a promo on this. I'm just so grateful that we get the benefits of his generosity, but he has the sourcing, the knowledge, so we've got a ringer in our corner for the extrusion. And that's really where it will start eventually when we get up to speed. That's where it starts, with the plastic. Passed on to the builders, or the printers, and then the builders, and all the way through the other parts, the people kitting and doing electronic rework. So it's just a really neat program. I'm getting excited about it, finally getting off and rolling. So our goal, for me, here's the goal. I would like to see a goal of 100 Adoptabots produced by Christmas. So 100. I did 50 myself, but I got to tell you, it takes a lot of time. The wiring, I have wiring machines, but I don't have time or the money or the resources to just donate all the wire, because there's so much work involved in that. I don't mind donating part of it, but it's the man hours I really need help with. Even the kitting of the parts, it's expensive for me to just give all this money away. So it's the community that's going to help get the cost down. So I can provide, on this 100, I can provide wire, I can provide bars, but when it gets to like bearings, I'm getting close to being out of those bearings. We're going to have to make a purchase, and that's why it has to cost something for the Adoptable. So that's all going to go through adoptable.org. We're going to make sure you have a real school that you can say, it's for this school, and you will submit. We haven't got it live yet, so give me a week to get that live, but you will submit the school and the teacher that's going to be the recipient. We'll reach out, hey, is this cool? You're on board? This is a real school. It's not like the Brookdrum School of Arts. Because some kids, I mean, God bless them, these kids are like, hey, yeah, $40 for an Adoptabot? I'm a student. It's going to my school. I'll do show and tell. It's really intended to be part of a program with people involved, supporting and teaching these skills to kids. So we'll vet a little bit on all of those 100 bots. And I need manpower to help vet these schools as well. So once they're vetted, and we're like, yeah, here's a link for whoever's building it or buying it or purchasing it, whether it's the schools, whether it's an individual that wants to take it to the schools and he wants to do the printing in the building. However that money comes in, it's going to go through adoptable.org. I want all the books to be super clean and apart from Printrbot. So that's how it's going to work. 100, and we'll stop at 100 and get that built. And then we'll have that time to see, how many nuts and bolts bags and how hard was that and how much time and how can we get organized for the next round. And maybe we'll just do 100 each round, but we can scale up as times go. So that's a lot about Adoptabot. Any other questions? I've talked long enough. Go get them files, start printing. You can feedback to the Adoptabot email address. Heather will be checking that for me. If you have feedback about anything Adoptabot related, please go through.
Adoptable at Printrbot.
Well, there is Adoptabot at Printrbot.com,
Oh,
but there is now,
there's a new one.
it must be info or something. Go to the adoptable.org website. And does it give an email address? You would think I would know this since I set it up. But I'm trying to, you see how I'm trying to move everything over there? We'll get real Adoptabot email addresses out to these leaders as well eventually. But anyway.
Yeah, right now the link takes you back to...
Okay, so let's use, for now, until I get my ducks in a row, Adoptabot at Printrbot.com, and I'll get that figured out later. But feedback on the files, to me, I'll be the one doing that. Questions to that address, again, Heather is our admin, and she's been enjoying working with the people that are emailing back and forth. And there's been a lot of emails flying, a lot of people trying to get in order, but I understand that you need a leader with clarity, which is my problem half the time. All right, so I'm feeling pretty good today because we did get out not only all the Adoptabots, but the prosthetics. There's a couple laggers that we got finished. They're under the table. They ship out tomorrow. And the Model 3 or the, I forget what he calls that. The big extrude, I showed the drawing last week. I got the parts in from FazTech, and so the model for the prosthetic, it's not, I've been calling it the Model 3 because I didn't have a better name, but he's calling it the 5400. He takes the inches, you know, width times height times width, length, width, height, and he comes up with 5400 cubic inches. But anyway, so that we'll start building tomorrow, and we should have something to show next week. And he's been sending me pictures, and that first one is going to be vetted by him in Lake Placid, but then it's going to go on to Nepal. And so there's a great story to tell about this prosthetic printer, the 5400. By the way, it's Create O&P, which I think is orthotics and prosthetics. But he's working with a bunch of other guys. Another guy, Matt, up in Canada, he's going to get a 5400 as part of a grant he bought. He's also getting the first 12-inch printer belt. So clearing my plate of this stuff that has been dragging on, it's now time to rock the 5400 and the printer belt, both sizes. So we're ready to roll. If there's nothing else, Dave, no? Guess I'm going to sign off. But good to be with you again. Check out the unboxing video if you want to see what's in the box. And have a great week. For those of you going to Maker Faire, I will miss you all because I'm not going. So staying home this year for the New York World Maker Faire, but I hope you're going. And have a good weekend. See you next week.